I request all the participants, please mute your audio. Shall we start, sir?
Yeah, yes, you can, please.
Okay, madam.
Okay, sir. One second. One small positive thought in the morning can change your whole day. Wishing you all a very happy and pleasant morning to everyone present here. It is indeed my pleasure to welcome you all on behalf of the SRM Institute of Science and Technology for the Day 11, 2 weeks online international faculty development program on the era of change, recent advancement of machine learning in terms of AI and IoT, organized by the Department of Computer Science and Applications. Now, I invite our Honorable Vice Principal, Admin S&H, Dr. J. Dileepan, to deliver the welcome address. Please, sir.
Thank you, madam. A very warm good morning to one and all. I am very happy to welcome you all to this day 11 of this 2 weeks online international faculty development program. It is my great pleasure and privilege for me to welcome our chief guest, Dr. Shaswan Siavik, lecturer, head of postgraduate program, information technology, Infrastructure University, Kuala Lumpur, Malaysia, with a deep appreciation for accepting our invitation in spite of his busy schedule. We are honored to have you as a chief guest on this special day. Thank you, sir. The topic of the today's session is Hybrid Intelligence System, Neuro Fuzzy Expert System. In general, hybrid intelligence is the combination of human and machine learning, expanding human intellect instead of replacing it. It is framed by combining at least two intelligent technologies like fuzzy logic, neural networks, genetic algorithm, etc. Fuzzy expert system can be used in many applications in the medical science presently, such as for diagnosis, patient monitoring and therapy, image analysis, pattern recognitions, and medical data analysis. So most of the research scholars doing the research in this area. So I hope the today's session will be more useful for all the participants, and you will learn many new things from this today's session. So once again, I welcome you all to this wonderful session. Thank you.
Thank you, sir. Now, I would like to invite Mr. N. Krishnamurthy, Assistant Professor, MCA, to introduce our chief guest.
Thank you, ma'am. Am I audible? Yeah. The
Yes,
chief
sir.
guest of today's function, Mr. Shaswan Siavik bin Mazlan, has completed his Doctor of Philosophy in the field of Electrical Electronic Engineering from University Kuala Lumpur Prestige Malaysian Institute in the year 2019. He has completed Master of Science Electrical System Design Engineering from University Science Malaysia, USM. He has completed his Bachelor Honors Mechatronic Engineering from University Malaysia Perils UNIMAC, grade with 2.86 in the year 2012. He has completed his Diploma in Mechanical Engineering with the major of Electronical Engineering from the University of Malaysia Perils. Coming back to his research activity, he has H index of 4 and citation of 61 plus. He has been member of professional bodies in various bodies like Board of Engineers Malaysia, Institute of Engineers Malaysia, Malaysia Board of Technologists, Malaysia Board of Technologists Professional Technology. And he has got 2 research projects granted for his credit. Short-term research grant, STRG, in the year 2016 to 18, and fundamental research grant scheme, FRGS, from the year 2020 to 2022, with the value of RM793520. And he has computer skills. To his credit, he has been a professional in National Instruments LabVIEW, Microsoft 2003-2007, Dev C++ and C programming, AutoCAD, MATLAB, CX programming, Intel 8051 assembler, Automation Studio, MPLab, IDE, Automation Studio, and Arduino programmer. Along with that, he has got a lot of engineering skills like conventional milling machine, conventional lathe tubing machine, welding, sheet metal forming, electrical wiring, electrical soldering, engineering drawing, basic electrical measurement, and artificial intelligence. He has got more than 15 years of work experience, starting from the year 2009 from K1 SD and PhD, Jabatan Kejeria Raya Kajwan in the year 2012, Mega Project Collaboration Malaysia Airport Holding Berhad. He has been a development of runway airways guidelines slide, lecturer and researcher at University Kuala Lumpur, lecturer and researcher at West International University Perth, lecturer and researcher at Infrastructure University Kuala Lumpur, and research project collaboration, Malaysia Productivity Cooperation, Augmented Reality, Virtual Reality, the 2019. So he has got industrial experience as well as teaching experience for his study. Coming back to his supervision, he has guided 2 students in Master of Electronics Engineering at IUKL, 4 students in bachelor level final year project, 2 theses at Infrastructure University Kuala Lumpur in the year 2020. 32 students have been graded in bachelor and diploma and final year projects with thesis at IUKL from the year 2014-2019. 2 students final year projects in the year 2019. He has been a book editor and he has got a lot of achievements like Bronze Award presenter in Novel Research Innovation Competition 2015, Gold Award presenter in 2014, Gold Award presenter Malaysian Research Conference Innovation in 2016, Platinum Award presenter by European Engineering Award in International Innovation Exhibition in the year 2016, Silver Award Productivity Innovation Exposure, Special Award Most Commercial Award Productivity Innovation Exposure in the year 2020. He has been the editor of journal for about 11 journals and he has published more than 10 papers in indexed journals. Thank you, sir. Your profile gives us enthusiasm to come to your. Thank you. Now the forum is yours, sir. Thank you for the opportunity given.
Thank you very much, Mr. Dilipan, and also for the very warm welcome by the VP Admin, Dr. JDD. And also thank you so much, Madam Suda, for the great introduction. All right, let me just introduce myself a little bit again. So first of all, my name is Sazwan Shafiq. I was born in the year of 88, and then my background a bit, if we look in detail about in the focus or area of artificial intelligence, especially in this area. So I've been molded with the AI field since back in 2006 when I started my diploma study at the universities. So for me, artificial intelligence is a very wide area which any one of the expertise can fit into. Right. Now, let's have a look about the today's presentation. The topics given is, sorry, the hybrid intelligence system. So for neuro fuzzy expert system, I would like to take this opportunity to thank SRM Institution Science and Technology Ramapuram for this grateful opportunity given to me to be one of your speakers. It's better for me to call this is more likely a sharing session knowledge. I hope you can hear my voice clearly, and I would like to also welcome some of my colleagues or staff, Miss Nasrin from Kuala Lumpur, and then I can see some Madam Ajila, Madam Ima. All right, thank you for joining for your time. All right, now, sorry, let's have a look about the, okay, this is my email. salva@iukl.edu.my. Feel free to contact me if you want to proceed for any collaboration or any research activities. So in my presentation for today, I will only cover these 5 topics, right? Because uh, we have such a very limited time, so only the 5 subtopics will be discussed or will be shared. The first topic, we start the engine with the neural expert system with the expertise embedded to the system, followed by the neurofuzzy, the rule arrangement, all right, in bracket priority, followed by the hybrid combined neurofuzzy expert system, then pass up to the intelligent system for decision making, and lastly into its application for swarm optimization to system communicate. I think I make it smaller lah, better. Yeah. Okay, please let me know if you can't see my slide or my video or my voice start. Please let me know. All right. Now let's have a look into the neural expert system. So what is neural expert system? Neural expert system is an artificial intelligence application that is used knowledge base of human expert for problem solving. In neural network expert system, the knowledge is encoded in the weight, and the artificial neural network or ANN generates inference rules. So these rules will be used as the sorry, as the guidance for the system about what should the system do and what type of decision making should give priority on. So the nervous system works through an interconnected network of billions of neurons. So these neurons transmit information in the form of nerve impulses across the nervous system and thus coordinate the various functions of body. So we consider these several intelligent technologies, including probability reasoning, fuzzy logics, neural networks, and evolutionary computational. So there's a strong and weakness point for this technology. So we do notice in this real world, uh, we would need not only to acquire knowledge from the various sources, but also not to forget to combine different intelligent technologies. So the need for such combination has led to the emerge of hybrid intelligence system. A hybrid intelligence system is one that combines at least 2 intelligent technologies. For example, we are combining a neural network with a fuzzy system result in the hybrid neuro fuzzy system. Also, you might think, what are these neuro fuzzy system? What are these neuro system? What are the expert system? I think later in my slide, we will discuss, I will share to you what are those terms mean. The combination of the probabilistic reasoning, fuzzy logic, neural network, and evolutionary computation form the core of soft computing, an emerging approach to building a hybrid intelligence system capable of reasoning and learning in an uncertain and imprecise environment. So the potential of the soft computing was realized. It was back, if I'm not mistaken, back in the philosopher of Zadeh. All right, Zadeh is a very is a how should you say is a godfather of artificial intelligence. All right, Lotfi Zadeh. So we used to call this person as the father of fuzzy logic. So he was the first person to invent or discover this fuzzy logic. In the year of 1991 March, he established the Berkeley Initiative in Soft Computing. So this group includes students, professors, or employees of private and government organization and others individual interested in soft computing as well. So the rapid growth of the group suggests that the impact of soft computing on science and technology will be increasingly felt in the coming years. Now, if we look carefully in this modern year, starting from 2015 onward, so the AI is start to spread very widely throughout the whole nation in the world. It can fit into every system in the world. I take a very simple example. Most of the students nowadays, or even us as a lecturer or academician, we are exposed to the smartphone technology. Smartphone technology, it combines a lot of AI technology. If we look very specifically into one particular system, the camera system, back in the years, those old camera system, it needs to readjust the focus point, all right, to get a clear, better, high resolution image. But nowadays camera, with just a few touch on screen, you can get a very good and I would say a very perfect image, you know. So what it do actually, even though it can determine or it can just the camera system, the AI camera system can determine which area or which boundary that it need to focus on and regards all the others uh, un, I would like to say uncertainty, or we call it a noise in the system. Yeah, this is how neural system works. All right. So the neural system is combination of it's a combination of small element that works in particular sites. For example, we have synapse. This is in our body, right? This is our neural body, neural system in our body. So we have a soma, we have the dendrite, the axon, synapse, and also on the other sides, we have a same system but collaborate and interconnected with this axon line. So same thing with artificial intelligence. When we have several systems acting together, collaborate together, making decision better. All right. So for our the intelligence system itself come from our body, come from the human thinking. A very simple example: if we are touching a hot water in the cup, let's say a hot water in the cup, then we just touch a bit. So this neuron will be passed from our hand sense or our what is it, our skin throughout the axon and also synapse, dendrites, and also soma back to our brain. So our brain, human brain, will determine whether what are the actions should be made. So the brain acting as the AI system determine, make sure that the decision that you make is good for the body. So this is happening very fast because the neuron inside us acting very, very fast. Some says that the neuron acting in us in human body speed up as a speed of light. So it's very fast. That's why if you do notice that if you are touching for the normal human, that if you are touching a hot water or hot cup, so you will reflect. So those reflect is considered to be a very fast movement. All right. So, but how do we put it in the system? So if you want to put it in the system must have the input, must have the knowledge. So for the system to have knowledge, the first layer should be the input layer. Input layer can be anything and any type. All right. Come to the process of middle layer. So middle layer is a combination. It can be a combination of several inputs combination of several layers of processes, or it can be shrink or expand to produce the action. Now, the action only can be accomplished by the output. So the output will determine what type of movement, action, decision that will be made. So not to forget, in control system, I mean AI is a continuous subject, or is a continuous program from the basis control system. In control system, we do have two type of system, the open loop system and also the closed loop system. So for the open loop system is a one-way flow. Now AI can fit into open system and also closed loop system. So but more likely, it will fit into closed loop system, whereby it do have a feedback from output to the input layer. So this feedback system is used by a certain or a specific algorithm that we call a tuning system. So this tuning system will tell the input to reduce, to expand, to increase, to do whatever it has to do to make sure that the targeted output achieved. All right. So this big thing, the big boss in the middle is what we call the neuron, right? So it will be supported by the input signal, and also not to forget, every input signal carries their own weight. So what are these weights do? This weight will give the input priority. For example, if we have the number of input of, let's say, x1, x2, and also xn. So for the neuron, the processor, the core processor, need to determine which input is more valuable. By giving weight to each input, it will give the priority to the input itself. I take a very simple example. I believe most of us, we do drink a tea or a coffee or a chocolate milk or whatever it is. So what are the most important ingredient in making, let's say, a cup of coffee? The first thing that you need to put on is hot water or warm water. Depends how we like to make it. If you're making an iced chocolate or iced coffee, then you will put a warm water. All right. Now, anything, if you put all the ingredients except the warm or hot water, so the output will not produce a good or perfect coffee. So that is why first thing need to do, if giving a very high weightage to the input signal, for example, like if you are discussing about coffee, so several amount of warm water is a must for the system to operate. Then you can just put some creamer and also some sugar. Depends how you would like to have it. Some of us put some honey to make the coffee taste better. All right. So how the expert system work? All right, this is very interesting. Okay, I would like to share a story, since we just call this a sharing session. So back in my days after my secondary school, uh, I was a very obsessed of I'm especially my ambition. I would like to be a medical doctor. All right, a medical doctor. But unfortunately, my secondary exam result is not qualified enough to be in that position. I mean, to further the study in medicine. So what I will do is, when I proceed my study all the way since 2016 up to 2018, I spent 12 years in engineering, and I figure out this is a very good opportunity that we can use artificial intelligence and grasp all the medical knowledge into it. most of the medical officer or the medical doctor, they have a very lack knowledge of artificial intelligence because they are not into the system. They are not into the instrument itself because all are in their head is all about medical or medicine. So what I was thinking that in my PhD, I was using algorithm, AI algorithm, which include machine learning, embed medical knowledge into the system. So the system itself will make the decision on behalf of the medical officer or the medical person. All right. For me, I use orthopedic and also radiologist. So I combine those two knowledge into a single system and start to produce a very precise and good output. All right. Because you need to bear in mind, uh, the evaluation of the medical evaluation is strictly based on data and also from their observation. For example, a radiologist is 100% based on the MRI image or X-ray image. So it's all based on the film. So every radiologist, every person have their own interception or perception interpreting the image. So what it will do is um, I develop the system, get every perspective person's knowledge, and then try to produce a very precise input, precise targeted output can up to 96.8%, which is very high to be considered in medical precision. So for user interface, okay, user interface is just what I mentioned earlier. Usually nowadays, all the medical interface, all these user interface are based on the screen. It can be on iPad or Android apps or TV or whatever it is. So it's a two-way communication. Now, the back end of the system is like you are putting a medical person or an expert into the system. So the person or the expert itself will will provide all the knowledge, all the rules in the inference engine. Sorry, in the knowledge base. So all the knowledge where the particular person study for like 10 years, embed everything into a mini library in the system. So from there, the decision making only can be controlled by the inference engine. So as I mentioned earlier, so this inference engine is a stack up of procedures, right? So it will determine what should you do first, and then followed by the other procedure. It's like a flow chart, you know. It's like a flow chart to make the decision. All right, hold on. Okay, I think I see. All right. Uh, what exactly are we are trying to combine in the hybrid system? So Lord Fizade is reputed to have said that a good hybrid would be a British police, German mechanics, French cuisine, Swiss banking, and Italian love. But British cuisine, German police, French mechanics, Italian banking, and Swiss love would be a bad one. Likewise, a hybrid intelligence system can be good or bad. It depends on which component constitute the hybrid. So our goal is to select the right component for building a good hybrid system. Each component has its own strength and weakness. Probabilistic reasoning in many concern with uncertain fuzzy logic, with imprecision, neural network with learning, and evolutionary computation with optimization. So it presents the comparison difference intelligence system. A good hybrid system will bring more advantage as we compare to some disadvantage or very low disadvantage of these technologies together. So their synergy allows the hybrid system to accommodate a common sense, extract knowledge from raw data use human-like reasoning mechanism, deal with uncertainty and imprecision. Not to forget, to learn, the system itself have to learn and adapt a rapidly changing in unknown environment. So this is very, very important for the system itself. All right, hold on. I think, yeah, okay. So we are correct, right? Now let's have a look into the approximate reasoning. As I mentioned earlier, reasoning is a term used as a procedure or the step or what we call the rules. Yeah, will be better. Rules is better. So the inference engines compare the condition part of each rule with the data given in the database. When the if part of the rule merge the data in the database, so the rule is fired and then the part is executed. So I think in firing uh, rule reasoning, we have two types. The first one is forward chaining, and then the other one is backward chaining. Correct me if I'm wrong. You can just find out these terms and also this technique in the Lord Fizade, Artificial Intelligence, a guide to intelligent system, fourth edition. All right. Now, if I can just focus about these two things, the neural network base, it consists of training data and also upcoming new data. All right. So this neural knowledge base will stimulate or have a look about on this new data to be classified on which term, on which field, and on which class. Then we do have a rule extraction. So this rule extraction is to combine the input and also the result together. All right. So that is why the rules given in here is if then. As simple as that. If you are doing A, then you will get B. If you are doing C, you will get D. As simple as in the term. But of course, in the real application, this if then is very well expanded. So these two knowledge has been combined together in the inference engine, as I mentioned earlier, and communicate with explanation facilities. So explanation facilities is depends on what system you are dealing with. If you are dealing with what you say automotive industry, so the explanation facilities might be a simulation of it. All right, simulation. For example, if you want to you want to develop or design a new car, so you are combining all these rules, everything in the single system. So the explanation facility is like a simulation system for the user. But of course, these explanation facilities will give you detailed report, will give you the analysis, will give you the fishbone theory, what are the pro and what are the cons. And all of this will be on screen at the user interface. So this user interface usually, as I explained earlier, it will communicate with the in terms of screen or the system of email and anything. Now let's have a look. What are the difference between the neural expert system, and also the expert system? So for the neural system is a parallel data processing modeling with a human brain. Looks at its ability to learn, synaptic with between neurons by learning phase of training set. As for the expert system, logical inference, decision tree, modeling, and human reasoning. And then for expert system, treat the brain as a black box. Expert knowledge based on if then by human expert. All right. So the neural system, if I can just conclude it, neural system is a data driven. Okay, it's a data driven, which for the expert system is for the goal driven. So the expert already know the end result. So what are the steps that you need to follow to be included in the neural system? So the knowledge embed to the entire network belong to the neural system, black box for its user, and also learn without human intervention, because the neural system itself can make their own decision. Now, as for the expert system, knowledge can be divided into individual roles, and user can see and understand the piece of knowledge applied. And the expert system cannot learn from experience or adapt to the new environment. Okay, because if we look back in the days, expert system in the, let's say, medical expert system back in the day. So they are evaluating a problem is based on their experience. Okay, it's based on their experience. So when the system or when the technology revolve, it's kind of hard for the medical person or the medical expertise to fit into the new system. But a good thing about the neural system is it can fit into any environment as long as the environment itself not giving the problem or giving the bugs to the staking procedure or steps or rules. All right, for neuro fuzzy system. So fuzzy system that uses a learning algorithm derived from the inspired by the neural network theory to determine its parameter. Okay, hold on. So the expert system and the neural system, as intelligent technologies, share the same common goals. So they both attempt to imitate human technologies and eventually create an intelligent machine. However, they use very different means to achieve their goals, while expert systems rely on logical interference and decision tree and focus on modeling human reasoning. Neural network rely on parallel data processing and focus on modeling a human brain. Expert system treats the brain as a black box, whereas neural network as its structure and function, particularly at its ability to learn. These fundamental differences are reflected in the knowledge representation and data processing technique used in the expert system and neural network. Knowledge is a rule-based expert system represented by if, then, production rules collected by observing or interviewing the human expert. So this task, called knowledge acquisition, is difficult and very, very expensive. In addition, once the rules are stored in the knowledge base, they cannot be modified by the expert system itself. Expert system cannot learn from experience or adapt to new environments. Only a human can manually modify the knowledge base by adding, changing, or deleting some rules. Knowledge in neural network is stored as a synaptic weight between the neurons. So this knowledge is obtained during the learning phase when a training set of data is presented to the network. The network propagates the input data from layer to layer until the output data is generated. If it is different from the desired output, an error is calculated and propagated backwards through the network. The synaptic weights are modified as the error is propagated. Unlike the expert system, neural network system can learn without the human intervention. However, in expert system, knowledge can be divided into individual rules and the user can see and understand the piece of knowledge applied by the system. In contrast, in neural network system, one cannot select a single synaptic weight as a discrete piece of knowledge. Here, knowledge is embedded in the entire network. It cannot be broken into individual pieces, and any change of a synaptic weight may lead to unpredictable result. A neural network, as in fact, is a black box for the user. An expert system cannot learn but can explain how it arrived at the particular solution. A neural network can learn but act as a black box. Thus, by combining the advantages of each technology, we can create a more powerful and effective expert system. A hybrid system can combine a neural network and a rule-based expert system is called a neural expert system or a connection-based expert system. Learning, generalization, robustness, and parallel information process make neural network a right component for building a new breadth of the expert system. So the basic structure, as I just showed to you, this one, this is the basic structure of neural network system. Unlike the rule-based expert system, the knowledge is based in the neural expert system is represented by a trained neural network. A neural expert system can extract if-then rules from the neural network, which enable it to justify and explain its conclusion. The heart of neural expert system is the inference engine. This controls the information flows in the system and it initiates inference over the neural knowledge base. A neural inference engine also endures approximate reasoning. In rule-based expert system, the inference engine compares the condition part of each rule with data given in the database. When is the if part and the rule match the data in the database, the rule is fired and then part is executed. In the rule-based expert system, the precise matching is required. As a result, the inference engine cannot cope with noisy or incomplete data. In addition to that, the system itself will produce an error, or if you are not lucky enough, the system itself will produce a very bad decision or bad output. Neural expert system use a trained neural network in place of the knowledge base. The neural network is capable of generalization. In other words, the new input data does not have to precisely match the data that was used in the network training. This allows neural expert system to deal with noisy and incomplete data. So this ability is called approximate reasoning. Now, as for the rule extraction, units estimates the neural knowledge base and produces the rules implicitly buried in the training neural network. The explanation facilities explain to the user how the neural expert system arrive at a particular solution when working with the new input data. The user interface provides the main communications between the user and the neural expert system. All right, hold on. Okay, let's move to the neural and the fuzzy system. All right, for the neural and the fuzzy system, neural network is a low-level computational structure which contains of raw data, and it can learn, but they are opaque to the user. As for the fuzzy system, reasoning on higher level using linguistic information from the expert. Right. So, fuzzy logic and neural networks are natural complementary tools in building intelligent system, while neural networks are low-level computational structure that perform well when dealing with the raw data. Fuzzy logic with reasoning on higher level using linguistic information acquired from domain expert. However, fuzzy system lack of ability to learn and cannot adjust themselves to a new environment. On the other hand, although neural network can learn, they opaque to the user. So the merger of a neural network with a fuzzy system into one integrated system therefore offered a promising approach to building intelligent system. Integrated neuro-fuzzy system can combine the parallel computation and learning abilities of neural network with the human result, with the human-like knowledge represented and explanation abilities of fuzzy system. As a result, neural network becomes more transparent while fuzzy system become more capable in learning process. A neuro-fuzzy system is in fact a neural network that is functionally equivalent to a fuzzy inference model. It can be trained to develop if-then fuzzy rules and determine membership function for input and output variables of the system. Expert knowledge can be easily incorporated into the structure of the neuro-fuzzy system. At the same time, the connection list structure avoids fuzzy inference, which entails a substantial computational burden. Now, let's have a look into the neuro-fuzzy system, okay, which I already explained earlier. So the structure of this neuro-fuzzy system is similar to the multi-layer network system. In general, a neuro-fuzzy system has input and output layer and three hidden layers that is presented a membership function and fuzzy rows. So usually in fuzzy inference system or fuzzy system, we have two types. The first one we do call it as a Mamdani, which is very well known or most popularly used, and the other one is Sugeno. Sugeno is very good, but it do communicate only like a binary communication. It can be either 1 or 0. It's just one spike in the graph, right? Just one spike in the graph. So it doesn't have degree of membership. And that one is in the Mamdani rules. Mamdani, we can have several degree of membership with probability from 0 up to 1.0. So at least the minimum that we can have is 10 points or 10 degree of freedom. 10 degrees of membership. So this every stage of degree membership can be expanded into 10 more layers. For example, from 0 to 0.1, we can expand it from 0.01, 0.02, 0.03, up to 0.09. So if we include all this together, originally we have 10 stages. Every stages have their own 10 procedures. If we multiply these two together, we might have around 100 steps of degree membership, which is quite a lot. So usually, layer 1 is the input layer. Each neuron transmit external crisp signal directly to the input layer. For layer 2 is the input membership falsification layer. So neuron in this layer represent fuzzy sets used in the antecedent of fuzzy rows. For falsification, neurons receive a crisp input and determine the degrees to which the input belong to the neuron fuzzy set. The activation function of a membership neuron is set to the function that specifies the neuron fuzzy set. In the example presented in figure 8.4, in the figure before, so we do have several layer of processor, right? So usually layer number 1, we call it as an input, and the final layer, we call it as an output layer. So the processing can be up to many layers that as you like, as long it will not affected by the targeted output. All right. Sorry. Yeah, this is what I explained just now. This figure. So the first the first layer is contain of crisp input. Okay. Layer number 2, you can have second layer of input with membership function. Third layer can be as the fuzzy rules, then followed by layer 1 output membership function. This is basically layer number 4, okay? And layer number 5 is defuzzification. In layer 5, defuzzification is usually we have this algorithm called COG, central of gravity. Central of gravity is like the middle point. What are the average? All right. I'm not sure, but throughout this pandemic, in Malaysia, every day we do have the the everyday reports about how many persons are get infected, new cases, and how many number of cases that were released. A cure and total of that given and that. So if you do notice, as for my fellow friends in IUKN, if you do notice, there is a specific term that is called R0. So this R0 is an indicator for all the user to be controlled. All right. So in fuzzy system, these R0 are known as COG, center of gravity. So this center of gravity is very important to determine what are the average reading, and it can predict what are we going to face in the upcoming, like a week, 10 days, 12 days, 15 days, or a month from now. So this R0 or DCOG is calculated very precisely based on the data. Only can be operated or only can be determined at the layer number 5, defuzzification. All right. So this is how it looks like if we have several parameters and we give weight to each link or to each input. All right, this is how it looks like for neuro-fuzzy system for this epoch. Okay, let's move on to the hybrid intelligence system. I hope if you have any question that you can just rise up from the audience before I proceed. Can I proceed or should we take any questions so far? I think it's better for me to proceed, right? Okay. Now, let's have a look into the hybrid intelligence system. As the first word known as a hybrid is a combines at least two intelligent technologies or systems with the probability of reasoning, fuzzy logic, neural network, and evolutionary computation for core soft computing. Use of approximate calculation to provide imprecise but unusable solution to complex computational. All right, hold on. Okay. Yeah, it's like you having a bowl with all the chips into it. All right. So, for example, if you went to the McD or go for the McD, you will have usually in every meal they will give you a French fries. So this French fries is a mixture of fries and also some sauce and also some, I don't know what's in it, but I assume it's a combination of several elements. So by the end product, it will give you a very good taste. So this is the comparison of expert system, fuzzy system, neural network, and genetic algorithm. Now, let's have a look into every characteristic. For knowledge representation, only can be denominated as fuzzy system and also genetic algorithm. Uncertainty, uncertainty tolerance, same thing, fuzzy system, neural network, and also GA, genetic algorithm. Then, imprecision tolerance, okay, same as the uncertainty tolerance. Adaptivity, also same. Learning ability, only can be only dominated by neural network and also genetic algorithm. Explanation ability, of course, the only one character dominated by the expert system, and then fuzzy system and also genetic algorithm. Knowledge discovery and data mining, only for fuzzy system and also neural network. So maintainability only for neural network. So what does it mean by maintenance? The system need to be maintained? Yes, because for every circulate, it called epoch. All right. For example, the system run for the first epoch or first loop, it will produce certain amount of error, even though it's minimal, but it's cumulative. If you are running 1,000 epoch or 1,000 loop, so combination of stacking of this minor error will reflect the system performance as the new input or new incoming input get it in. All right, now let's have a look into the intelligence system. So as the topics known as the intelligence system, intelligence means up to certain part of knowledge that the decision that the system itself can make its own decision. So that is why intelligent system is very well known as the decision making, a process of selecting the best or the most suitable alternative out of multiple alternatives to reach the desired goals. Application, a lot of all right, in intervention for healthcare, automotive industry, Volvo in manufacturing, and underwrite for financial services. Yeah, it's quite a lot. Okay, it's quite a lot for intervention for healthcare. For example, CT scan. Now, CT scan is a series of brain image. Okay, it's a series of brain image to ensure that the black spot or the disease can be spotted in every angle. Okay, so that is why it's very important to have multiple image. So this multiple image will be included or will be transformed into AI data and cumulate and process into the system to produce a single output. So that is why sometimes most of the medical expert, because we are just relying on our eyes capability, our sight capability, but up to certain knowledge, up to certain age, for example, up to 60 or 70, our vision is start to blur a bit. All right, it start to blur a bit. So that is why we are start to make a unprecise or imprecise decision. But not for the system. Systems never get old because system is always upgrade from time to time. Now let's have a look into the final part or final topic in this session is combination of intelligent system, hybrid system, neuro system, expert system, and also fuzzy system. So this is a particle swarm optimization. All right. I'm not sure whether swarm optimization in Malaysia is starts to spiking up. Now, what is swarm optimization? Excuse me. Okay. Uh, I'm not sure whether you can see my screen or not. Can I have some feedback? Is it everything's okay, or I just speaking along myself?
No, sir, the screen is visible, sir.
Come again?
The screen is visible and your voice is also clear.
All right, thank you very much. All right, swarm optimization is it's like what is it? If you have a humanoid robot, and you give instruction to this robot, pick up the table from the floor. So do you think a long table, let's say like a 10 feet table, okay, 10 feet long table. So the robot itself unable to pick up or stand up back, put it back in place. I mean the table itself to its origin position. Because why? The robot itself knows that there must be some lack, there must be some limited up to the robot's capability. So what it will do, this humanoid robot will communicate with another humanoid robot. So let's say you are I am the A robot, so I have another B robot. So this between two robots communicate. B robot go to the end of left side, and I go to the other end of right side. So these two robots communication is cooperate each other and then start to perform a single or a task. All right. So this is very, very, very good, because nowadays swarm optimization is start to taking place. All right, hold on. Yeah. Earlier we discussed about the intelligence system. Now, what it has to do intelligence system and the swarm optimization. Swarm's algorithm is a combination of several intelligence systems. You know, a robot itself is considered to be an intelligence system. So how to make intelligent communicate with intelligent? That is what we call a swarm optimization or swarm algorithm, where only intelligence system communicate with intelligence system. Now, it's like more likely a chicken talking to the chicken. So you cannot have a chicken talking to the dog. So you must, the system itself must speak into the same language. Yeah, this is quite a lot of equation. If we look into this, what is it? This flow. So we have the end compressor. You know, this is one of it, because in manufacturing, I think this slide is focusing into the turbine is more into the industry, machine industry. So air compressor have their own system, preheater, combustion chamber, turbine, and also heat recovery. Every one of this compartment of this element is it have their own intelligence system or their own detail system to operate. So operating between all these systems, this is one of this optimization system. All right, I think that's our presentation for me. So I would like to take any question from the floor, or I just send it back to the MC.
Thank you so much, sir, for such a wonderful session. A gentle reminder to all the participants, the feedback link will be posted in the chat box. Kindly fill it, and also you can unmute yourself and ask your queries.
Okay, please.
Participants, you can unmute and ask your queries. Okay, sir. Thank you. Now I would like to invite Mr. D. Rajkumar, Assistant Professor, MCA, to propose the vote of thanks.
Good morning. It is indeed my great pleasure to propose vote of thanks for this today's event. Sir, we are extremely grateful to have you in your midst, and thank you for your lecture, sir, especially in understanding the very basics of natural expert systems, and thank you for the very basic and very clear explanation about how the neural system works and how the expert system works, and we also taught us a very good explanation about neurofuzzy systems. We are extremely happy to have you, sir, and we like to look forward to the upcoming events also. Thank you, sir.
Most welcome. Most welcome.
Thank you, sir. Thanks a lot. Thank you for joining us. Participants, the feedback link has been posted in the chat box. You can fill it. And tomorrow the session starts around 10 o'clock. We'll meet around 10 o'clock. Thank you, participants.
Thank you very much for the opportunity given. Have a good day and stay safe, everyone.
Thank you, sir. Thanks a lot, sir.
So is it end now?
Yes, sir.
All right. Okay. Thank you.